Thank you for viewing this recorded Reliable Automatic Sprinkler Company webinar. Should you have any questions regarding this presentation, please feel free to contact Reliable Technical Services at 800-557-2726 or email us at techserve@reliablesprinkler.com. For upcoming webcasts and an archive of past webcasts, please visit reliablesprinkler.com/webcasts. Once again, thank you and enjoy the presentation.
Thank you everyone for attending today. As Lindsay had mentioned, this is part 2 of a 2-part series. Part 1 covered the protection of attics using standard spray sprinklers and how we get to using attic sprinklers that are special sprinklers listed under Rise Laboratories. And today we want to deep dive into the Reliable attic sprinkler product lineup, the models, the applications, and some hydraulic examples, and just give you guys a sense of what's available to you when it comes time to estimate, design, and install a system that protects an attic. Picking up where we left off last time, we mentioned that we have 4 unique models in our lineup: our DS, which stands for direction single, our DD, which stands for dual direction, our GP, which is a general purpose sprinkler, and AH, which stands for attic hips. And these are all UL listed, and the complete information for these types of products are published in Technical Bulletin 056, available on our website. Every one of these attic sprinklers that we discussed today are going to be listed with a 175 PSI maximum operating pressure. And every single one of our sprinklers uniquely in this type of lineup has a 212-degree fast response fusible link operating element. In this day and age, many in the fire sprinkler industry just assume that the orange plastic operating element protectors are required on sprinklers. Well, we're here to tell you they're not. Fusible link sprinklers are more robust and durable enough to not require the need for that type of extra level of protection from the manufacturing, shipping, handling, installation perspective. As I said, all of Reliable's attic sprinklers implement a fusible link operating element and do not have to have those orange protective covers. What's important about that is, number one, we have these operating elements that are more robust. These are sprinklers that are going to be installed in concealed spaces and not be looked at if ever once they're installed. And importantly, with the lack of an orange protective cover, it means that field personnel won't forget to take them off, necessitating a punch list item where they have to climb up into the attic and remove them, one or more of them. So just one of those nice little benefits to these types of attic sprinklers versus the competition. The other thing to understand about all attic sprinklers is that they are listed for use with roof slopes. And you'll be able to find roof slope applications for this type of sprinkler that range from 3 and 12 up to 12 and 12. And that's really just a ratio of the span over the rise when we talk about that. With Reliable, we're able to offer these spans that you see here, 4 and 12 up to 8 and 12, utilizing our sprinklers. If we take a look at this in application, what we'll do is most commonly look at a roof plan and try and assess the different roof pitches that we see. And in this instance, we see a lot of 4 and 12 and a lot of 8 and 12, and that's just giving us a green light to say, hey, go ahead, apply Reliable attic sprinklers without any concern. However, we could also be looking at a plan with the same geometry, but essentially has much higher roof slopes, 10 and 12, 12 and 12. It's rare to see this type of construction due to the added cost that comes from building a roof this high. A lot of times we're trying to build it as low as possible to save cost, but when it does come up, that would basically eliminate the ability to use Reliable attic sprinklers in this application. One thing that does pop up from time to time is a situation like this where we have 6 and 12, and then all of a sudden we see just a very small dormer attached to the front of this building or sides or wherever, just something to give it a little bit of architectural flair from the elevation view from the street. In this instance, you can use Reliable attic sprinklers throughout the entirety, the majority of this attic. And what ends up happening is that you need to look at alternative solutions for that dormer area. And it could be as simple as adding some standard spray upright products from us, and you'll be good to go. And all that stuff is detailed inside of our technical documentation. The other unique thing about reliable attic sprinklers is we need to understand how we measure using the products. And there's two unique measurements we need to be concerned with. First is coverage area. And coverage area is actually measured flat with these products. If we think about standard spray products and we think about other attic sprinkler products that have been on the market for many years, coverage area has always been measured along the slope. And that actually is something that causes you to use extra sprinklers throughout the project. You're really not able to maximize the coverage area for the product when it's being used on a slope. So this is a great benefit with the reliable attic sprinkler lineup. The next measurement that we need to be concerned about is cold solder, the distance between these sprinklers. We want to make sure that they will operate and that when one operates, it will not be wetting an adjacent sprinkler, preventing its operation. So we chose to have the cold solder distances measured and applied along the slope. What that does is it gives you the maximum amount of coverage area by measuring it flat. And with the cold solder measuring along the slope, it makes it the shortest distance possible. So our measurements are actually applied in the best way possible for these types of products in both cold solder and coverage area. With those basic principles out of the way, we can move on to talking about our 4 different attic sprinkler models. The first one we're going to discuss is the model DS product, and this stands for our direction single. We'll most commonly be applying this in attic space that you see depicted here on your screen, placing it at or near a peak, and its spray pattern is meant to throw in one direction only. And that would be a maximum of 40-foot span in this case. It's not out of the realm of possibility to install these in a back-to-back orientation. The only key to doing this is to have a draft curtain that separates these types of products there. That's mainly for aiding in activation of these products. It's really nothing else to do with the coverage area of the product. In doing that, we'd be able to cover an 80-foot maximum span. So one sprinkler does 40, 2 sprinklers do 40 each, makes 80. This is not really a common situation where we would see people wanting to do this, electing to do this, and really going up to 80 foot would be one reason to do that. But another more relevant type application would be mismatched slopes. So we have this slope on the left being 5 and 12 and the slope on the right being 7 and 12. And if we wanted to put a single sprinkler at the peak, we would not be able to cover those 2 slopes because the listings for those types of products don't allow for such a big difference in slopes on one side to the other. It's not impossible to do it when they're a little bit closer, but in this case, they're 2 inches apart and they just don't fall in line with a listing from other sales products. So if we want to do special attic sprinklers, we would need to look at possibly doing this type of arrangement, installing a draft curtain, installing a line of DS56 on each side of it, and being able to get the coverages that we need. In this case, both sprinklers would still be able to cover a maximum of 40-foot span, depending upon how far they need to throw. These types of sprinklers implement a 5.6 K factor. That's the only K factor we have for it, 5.6 half-inch threads. We have the 4 and 12 to 8 and 12 listing, and we have a 6-foot maximum spacing at the peak. And our installations for this type of product looks like this. So we need to install it 32 to 40 inches maximum from the peak. If you have a setup like this, we would need to have that draft curtain installed. If the attic was more of a right triangle and that did just have a back wall there, that's fine. We don't need to install a draft curtain because the wall of the attic framing would act as that. If we're going to install that draft curtain, we need to be aware that it's important that it goes 8 inches minimum bottom of the draft curtain to the top of the deflector. So we have that distance we need to have that installed at. And our installation dimensions 9 minimum, 13 maximum from the deflector to the deck. What's unique about this product, though, is that it does have a requirement to have the frame arms installed perpendicular, 90 degrees, to the roof deck. And this is a big differentiator for this type of product compared to competing products that are out there. The competing products would ask you to install these products as an upright, and they would also ask you to purchase unique models that match the roof pitch. So we chose to go a different direction. We made a universal product, one sprinkler, and we just asked that at the time of installation, it be installed with the frame arms perpendicular to the roof deck. And we think that's a more efficient way to go about doing it. It also prevents any kind of issues where the field might actually install the wrong sprinkler in the wrong location if there's multiple versions of this product on the market or on the job site. So it is a very good way to probably approach doing this single direction. We're only concerned about throwing one direction. Let's make sure we install the product correctly and it will do what we need it to do. The product has two coverage areas with listed flows and pressures. We have a 6 at 30-foot span and we have a 6 at 40-foot span. And you see the resulting flows and pressures for the products. Now let's move on to the most popular type of sprinklers in our attic lineup. These are our DD products, our dual direction. You install the sprinkler at a peak and the flow is meant to go in two directions. One on one side, one on the other. That's where we get the dual direction nature of these types of products. With our DD56, we can have a maximum span of 40 foot. Now the DD56 comes in two unique models, the DD56-6 and the DD56-27. The way we chose to name these types of products is DD for dual direction, 5.6 or 5.6 is meant to be a 5.6 K factor. And then the -6 and -27 are going to be a reference to the angle of the deflector. So if we take a look at this deflector, the way it's bent down right here, that's our -6 model because it's a 6-degree bend on that. And then if we look down here, it's a little bit more of a bend, more severe. That's going to be our -27 product. And again, that's a 40-foot maximum span, 6-foot spacing at the eave or at the peak. There is listed flow and pressure for these products. We have single flow of 6 by 40, and that's 25 gallons a minute at 19.9 psi. The DD27, same situation, 6-foot coverage, 40-foot span, and we have 25 gallons a minute and 19.9 psi. Moving on to our next sprinkler, we'll talk about the DD80. Now the DD80 is going to offer us coverages that exceed 40 foot. So we'll place that sprinkler again at the peak, and now we'll be able to offer 60-foot maximum span. Now 60 foot has been the maximum span listing for these types of products for over 2 decades. So when it came time to come up with our product, we said, how can we do better than 60? And fortunately, we had some very sharp engineers that were able to figure out listing our product flat, not using our coverage area along the slope, also some very unique deflector designs, and we were able to push that coverage area all the way out to 66 foot. And that's considering that we use a 6-foot spacing at the peak. So huge quantum leap in coverage for that 6-foot spacing at the peak to be able to go to 66-foot maximum span. And that's from a 4 and 12 slope all the way to 8 and 12 slope. Nothing changes. It's always the same. But as I said, we had some very good engineers, and they actually were able to pull out another one, and that is 70-foot maximum span. In order to get to 70, though, we had to then compress our spacing at the peak down to 5 foot. So what we're dealing with here is a limitation of NFPA 13. That particular standard states that no sprinkler will be able to cover greater than 400 square feet of coverage. So when we look at the math, if we were to get a 70-foot listing with 6-foot spacing at the peak, that would be 420 square feet. So the compromise at the Underwriters Laboratories was to reduce the spacing at the peak to go 70 foot by 5 foot, and that's 350 square feet of coverage. And we're actually complying with NFPA 13 at that point. So it's very beneficial. If you need to go to 70, you would happily compress the spacing at the peak down to 5 or something else, so you didn't have to run additional lines of sprinklers. It's a small price to pay to put more sprinklers at the peak than opposed to running additional lines. As we mentioned before, there's two models for this type of sprinkler in our product lineup, the DD80-6 and the DD80-27. These are, again, referring to the angle of the deflector for these products. And as I said, maximum of 70 foot, and that's assuming that our 5-foot spacing at the peak is met. From an installation standpoint, we're going to place this at or near the peak. We do have the ability to install this laterally 6 inches away from the peak. And then our deflector distance from the peak is going to be 17 to 21 inches. Fairly simple. When it comes to designing this product, you're going to open up our bulletin and you're going to see something that you're not going to find elsewhere. And that is 4 coverage area listings for this type of product. And we're going to take a minute to talk you through each one of these, because this sprinkler, more than any other in the lineup, is probably going to decide if you're going to use these types of products from Reliable, and they all have unique benefits that are pretty important to point out from a design perspective and an estimation perspective. First is the 6 at 40. The idea of having an 8.0 K factor in a dual direction product with a span of less than 60 is not something that everybody does. But we have this 6 at 40 listing, and what happens here is that we're able to take advantage of the larger K factor, the 8.0 K factor versus the 5.6s in this 6 at 40 instance, and have a very low end head pressure. So we have this 9.8 psi. That's really good from an attic system standpoint. To be able to start at that low pressure is pretty key. It might mean the difference of you using these products or not using these products. And we know that not every municipality offers very good water pressure. We also know that attic systems and these sprinklers especially are going to be the highest point in elevation. So you're going to lose an already low amount of pressure. You're going to lose even more by going all the way up to the very top of this building. So having a lower end pressure for this product is really key. Now the next listing you'll see is 6 at 63. We mentioned before that 6 at 60 has been the standard for this industry, for this type of product for 2 decades. So why do we not have a 6 at 60? Why do we go to 6 at 63? Well, it all has to do with how we list the product with the flat spray pattern. By doing that, we can push the coverage out to 63 feet, and you'll see that the flow rate is 38 gallons a minute with a 22.6 end pressure. Now, I don't know if any of you guys listening today are really attic sprinkler experts, but that 38 gallons per minute and that 22.6 psi is actually the competing listing for products at 60 foot. So we can equal them with flow and pressure and give an additional 3 foot of coverage. So that's pretty nice. When you're all equal on hydraulics and you can squeak out a little bit more coverage area, that can be huge, especially with these attics where we see sometimes they just cross 60. They go to 61 feet, and then you're in a whole new world of how to apply these products. Well, a product that goes to 63 is pretty beneficial in that regard. We mentioned before that we have this 6 at 66. This is the most demanding flow and pressure for any attic sprinkler product on the market. It needs 2 additional gallons per minute, and it needs about 2.5 more pounds to work. But man, if you have an attic that goes out towards 65 feet or 66, right on the money, you're gonna upsize that pipe. You're gonna find a way to make that work, and you're gonna be glad that this product has a listing that can get you all the way there, because the alternative is more lines and more sprinklers. And then those more sprinklers are added to the calculation, so the calculation gets worse. And we look at this last one, the 5 at 70. I mean, when people think about the idea of using an attic sprinkler to go to 70, that gives them a little bit of pause. They're like, I don't know if I'll be able to make that work because I can't sometimes make 60 work. Well, that's the really nice part. By compressing the space down to 5 at the peak, we don't need to flow a lot of water to make that work, because we're working off of the idea that we're using light hazard flow rate of 0.1 as a minimum. So this 350 square foot of coverage per sprinkler can work with 38 gallons a minute. And then we know that 30 gallons a minute needs 22.6. That sounds familiar. Look up 2 lines. You'll see that's our 6 at 63. And I just told you that the 6 at 63 is the same as 6 at 60 from our competition. So what we're saying is that if you need to go to 70-foot spans, hydraulically, it's no different than what you're dealing with at 60 today. So all 4 of these have some very great value when it comes down to doing your design. And none of these numbers, none of these spacings should scare you. They're all right in line with what you would expect for attic sprinklers. And, we'll show you some more about that in a little bit too, about hydraulics too. What do we do when we have a span that exceeds 70? Well, we know we can't use a dual direction product, so we need to add additional sprinklers. We would propose using our GP56, our general purpose 56 product. With those 3 sprinklers paired together, we would have the ability to go up to 100-foot maximum span. So our DD80 could cover 70, and then each of those GPs would be able to cover 15 foot. So it's a really, really great extension of this type of system. We would get an additional 30 feet out of those 2 products. Now, if 100 just isn't cutting it, we have the option to design and build this monstrosity we see here, which takes our DS products, puts a draft curtain in the middle of them. We know each one of those can deliver 40, and now we add our GP56s, each doing 15, and now we can get to 110-foot maximum span. So I just want to take a minute to talk about these max span numbers. We know that the DD80 can deliver you 70 foot with a single sprinkler. That's a huge improvement. That's 10 foot greater than competing products that are available. When it goes beyond 70, we have to look at adding additional sprinklers, as we just talked about, the GP, and that gets us to 100. And if we do this one, we get to 110. What's important to note is that competing products, you can probably find a solution that goes to 84 feet. Most are relegated to 80 feet. Now, I don't know how many attics you see that do cross the 80-foot mark or the 84 mark, but one thing to keep in mind is that if you do see something very large span-wise, Reliable has you covered all the way up to 100 or 110 with these 2 solutions, a significant increase in improvement versus competing products that are out there. So mega spans, just think Reliable. We'll be able to help you out. With our model GP product, it is a general purpose sprinkler. The K factor for this product is 5.6 and has listings for 4 and 12 to 8 and 12. The total coverage area of the product is 150 square feet, and that's got some unique things that we'll talk about in a little bit. The primary use for this is meant to be extending sprinklers at the peak, right? We just showed you some demonstrations of that. You can use this for dormer construction, and then also if it's beneficial in obstructions and other things. So very unique general purpose type product. When it comes to installing this product, it's going to function very much like a single direction product. So we need to look at installing this correctly. It has to go in facing the right way. So in this instance, it's actually in backwards. We need to turn the sprinkler around and make sure that the open side of the deflector is going to point towards the eave. We have stamps on the deflector that actually indicate where the flow needs to go, where to point it at. So it is very clear to the installing personnel. If we take a look at the expanded coverage area offered by the GP56, in plan view, this is how the product looks. So we have our full 15-foot measurement for the product, but we'll see we get a lot of coverage out the front of the product that goes down towards the eave, so 12 foot, and we don't have much flow out the back. It has a little bend in the deflector that really knocks the pattern down on the back and the sides of this. So we got 5 foot, 5 foot, 3 and 12, so that's 10 by 15. Now, if we take a look at how competing attic uprights stack up in this application, we're looking at a much smaller coverage area that is 10 by 10. So 100 square foot versus 150. That's how we get that much greater coverage area out of the product, all the way to 100 foot, in certain instances 110 in others. But I feel like looking at this in plan view doesn't really convey the true power of this type of product. So let's turn this on its side. Here we have this GP product installed down at the EAVE. And we can see here that we'll install it. This is our measuring point down at the installation. And we have the ability to install this 12 foot in the back here. We want to install it, I feel, 12 foot back. You want to take advantage of installing that as far away from the measuring point as possible, because that geometry in the attic, this triangular geometry, means that the further back you are, the greater this measurement is. And having that measurement be greater means that it's easier for field personnel to work. You know, if we put them down further here, it's not a good thing. You just don't have much room to work. This GP product has the ability to be installed anywhere we'd like in this green zone that we've drawn on this picture right here. So it is very flexible from the dimension that you put it in. As I said, the 12 foot is probably where you want to try and optimize this for, and maybe you just move it forward by a foot or so to try and miss some framing member. But obviously you want to be as far back as possible, give as much coverage area and give as much room to work. If we look at how this stacks up to our competition, they have a very different way to lay this out. It's 4 foot or 6 foot from the measuring point, and it's measured along the slope, because we said that's a big differentiator of our type of product. And that little red stripe that you see there is the only area you can install that product. And also important to note is that the stripes are meant to indicate the area where you could place the deflector, how thick they are. So we have this 1 to 3 inch maximum from the area to install this deflector, and we have this 9 to 13. So that's a 2 inch area to install the deflector for that product. That's a 4 inch area to install our product. What that means is that on a wet system, it's not going to mean anything to you. On a dry system, however, where we're concerned about pitching and we want to install these sprinklers attached direct to a branch line, the reliable GP is going to be able to have a 80-foot long branch line, and you're going to be able to install it with a pitch, and everything's going to be fine. With the other products, that 2 inch area is going to mean that you have to do a 40-foot maximum branch line before you're going to run out of the ability to pitch being attached directly to the sprinkler piping. So model GP has a minimum flow and pressure listing, 10 foot by 15 foot coverage, 17 gallons a minute, and 9.2 psi. One other thing that's not really clear, not really laid out on our bulletin, is another way to apply this GP product. While we originally had envisioned this product as an extension of sprinklers at the peak, we were asked frequently, can I use this product on its own for a very short triangular shaped roof like we see here? And naturally, we talked to UL, and they were fine with the application. The thing about understanding the application is that it wasn't something that was fully tested, and that brings along some caveats. Number one is that you just can't use CPVC piping with this. You have to use steel piping. Until we validate this with some type of testing, we can't really permit the use of CPVC with this sprinkler alone on a single line like that. And then with calculations, because we didn't run the test, we don't know how many of those heads are opening up. We're just going to have to default back to what NFPA 13 would say. So if we have a single line of these sprinklers installed in that area, we would use NFPA 13 special design areas criteria that states that you'll calculate a single line of 7 sprinklers, whether they're wet or dry, and that'll be it. Now this application is very beneficial from a standpoint of our alternative in this type of space would have been to use 2 lines of standard spray sprinklers, which is just really not that great. So you have to put one up here at the peak, and then we have to put one further down here to get the coverage near the eave. But if we want to do this with attic sprinklers, we would end up installing in this area a single direction. Now, these single direction products, they're meant to, cover a greater area than this geometry that we're looking at here, 15 foot. They're meant to cover to 30 to start on the low end. And they're also closely spaced. They're 6 foot apart versus the 10 for this type of product. So we can have a much lower flow and pressure requirement, and we can have greater distance in between sprinklers. So it's much more economical to go about doing it this way. And like I said, the only thing that's really an issue with applying this, I think, in some areas is the lack of CPVC, because we know people are doing attics and CPVC, and that's a huge, simple piping material to use in that type of space, and you want to take advantage of that if you can. Now, our goal is to better spell this out, at least in its current form on our bulletin. So hopefully, as you apply these sprinklers and look through the bulletin in future revisions, you'll see more applications that look like this. And maybe someday we would actually go back to the lab and run some testing and try and get better hydraulics and better CPVC usage with this type of product. When you're applying the product in this manner, you want to also be aware of how the mansard roof is actually framed up. A lot of times it sits on the building. Sometimes it overhangs off of it. In this instance, we need to make sure that we have a greater than 36-inch clearance there that allows the sprinkler to flow its water into that space and not be obstructed by any kind of pinch point here. So that's just one thing to keep in mind as how that mansard's framed up with this type of sprinkler application. Moving on to our fourth type of sprinkler, our model AH attic hip. This comes in two K factors, 4.2 and 5.6, and has those listings for 4 and 12 to 8 and 12 we talked about. We'll install this sprinkler parallel to the roof deck, and the coverage area for this product, again, just like the GP, is going to be 150 square feet. And our primary use for this type of product was those hip sprinklers, to hip applications, whether they're framed up with traditional dimensional lumber or they're using the engineered trusses. That's the primary application for this. It could, of course, be used for obstructions, and it could be used for dormers as well. But if we look at this is a section view of one of those hips using those engineered trusses that step down as they go towards the eave. And we have no restriction for this type of application. It could be as long as we want it to be and as high as we want it to be. Other products on the market actually do have restrictions on how big the hips can be and how tall, subsequently how tall the hip can be as well in certain regards. If we take a look at our figure here, this figure comes out of our bulletin, and it discusses some concerns and what we need to be looking at when we're applying a design of the model AH product. Our first thing we need to do is be aware that the line of AH sprinklers has to be installed on the inside of what's referred to as a girder truss, and that's a large piece of wood down here that is framed up with some type of open webbing. Sometimes it's two of these step-down trusses together, and really because it has all that extra lumber there, we need to be concerned about that as a obstruction to flow. The easiest way to be unconcerned about that as an obstruction to flow is just say, hey, I'm putting my sprinklers on the inside of it. So they're going to be able to deliver their flow down to the eave without any kind of problem. Once we do that, set that up, we're in good shape. If I was to do a design, the next thing I would do is focus on laying these sprinklers out here. And what that does is create like a U that runs around the eave of the building. And my next goal would be to run another U-shaped line of sprinklers right on the inside of this. And when we're doing that, we need to be concerned about creating a 2-foot lateral offset. And this is something that UL has imposed upon attic sprinkler technology. If we line these sprinklers up in the same truss line here, the concern is that a fire that starts in the eave down here could end up sending all its heat and smoke towards the peak, and if these are spaced far apart, because they could be up to 10 foot apart, we might bypass them. But if we impose this idea of staggering them a minimum 2 foot, then we move them over into this truss pocket, there's a chance. There's a small chance it'll work better. It'll catch that fire and the byproducts of combustion and activate it. So that's why UL imposes that upon us and upon other manufacturers. And if we do think back to NFPA 13 standard spray, there's no such requirement. If we wanted to line those sprinklers up, we could. The only difference is that we're probably going to be spacing them 8 foot apart because of the hydraulic benefit of not exceeding that 8 foot measurement and using that 20 psi end pressure. Now, as I said, we do the first loop, we do a second loop, and then more than likely we need to put one sprinkler up here at the top. We do have a special provision here that allows us to use a standard spray upright in this instance. Now, we could use an AH56. There's no problem. You don't have to do this. But you'll find that the cold solder dimensions of an AH are a little bit greater than standard spray uprights are with the 6 foot. So in this instance, if you just have this issue of placing a single AH up here because of cold solder, you could switch this out to a standard spray upright, something like our F1 FR 5.6 product, and that would not hurt you in any way. No issue with how you hydraulically calculate. You'll still add that sprinkler in there. You'll calculate it to make sure that you're delivering the right flow out of that product for light hazard. But that's it. So it is nice. Also, if you're doing this HIP in CPVC and you use that standard spray up right there, you can do that and still feed it with CPVC and there's no problem there. Because we all know that with CPVC, whether we're using it in concealed combustible spaces, we have to use those concealed combustible space sprinklers, and we use it in attic, we have to use specially listed attic sprinklers. This is one of those things where you just can't do it with standard spray, but in this one small instance, UL will allow us to do it there. And that, again, doesn't affect anything with CPVC or hydraulics. Now, this product has some unique coverages, which we're going to touch on in a minute. But we do want to install it correctly. And the first thing we need to do is make sure that the deflector is 1 to 3 inch below the bottom of the top cord. Now, we have to install this product correctly. And because there's a bit of a unique spray pattern, we got to make sure that the window of the sprinkler looks down towards the eave, or that the frame arms are parallel to the eave. And like I said, this is all due to a unique spray pattern, which we're going to show you next. So this is our spray pattern. If we lay this product out in plan view, you'll see here that we get 15 foot and we're going to get 10 foot across here. But what we would expect to see is maybe like a symmetrical spray pattern, both side to side, and then also up and down the slope. But we're not getting that. We're actually getting a 9 foot out of the front of the sprinkler down towards the eave, and we're getting a 6 foot out the back. We have to install this product underneath of a slope. So that means it's naturally going to be tipped, but just like this. Now what happens is when we flow like this, it'll hit the deflector and that flow will go down this way. Now because we're positioned correctly to send the water down to the eave, we can get that great 9 foot projection down to the eave without any kind of problem. In this direction, we're also sending the water this way, but what happens is gravity actually pulls the pattern down, so we don't get as good projection backwards. That's why it's a 6 foot. The pattern just falls off in this direction, 9 foot, sends it down towards the eave. So that's what's going on with that installation. Comparing this to other competing products, it gives you that spray pattern that we just discussed. It's more logical, where you get even distribution in between the sprinkler side to side, and then you get even distribution up and down the slope. So in this instance, that's 150 square foot for the Reliable product, and this coverage area is 120 square foot. But we have mentioned today that how you apply that coverage area is really crucial. So if we take a look at this here, we'll see that whether it's a 4 and 12 slope, we're able to deliver that full 15 foot maximum along the floor of the attic to give you 150 square foot. And if we look at these competing products, because that 120 is measured along the slope, we've now decreased our amount of coverage area. So what looked like it was going to be 120 square foot for that type of product, in reality is going to be 114 and a half in this 114 square feet in this instance. That's a 4 and 12. Now, if the slope actually increases, things get worse for the competing products. We still, with Reliable, deliver the 150 square foot, 15-foot maximum along the floor of the attic. But now we see that this product here, measured along the slope, takes you down to 10-foot measurement. 10 by 10 is 100. What that means is that we have 150 in all applications for Reliable. And with the competing products, we're looking at best case 114 square feet, and in worst case 100 square feet per sprinkler. We mentioned before this product was primarily for the dormant, for the HIP applications. With this sprinkler, you do have the ability to use it to extend sprinklers at the peak, just like the GP we talked about earlier. And in that instance, comparatively, products from our competitors are 100 square foot. And we all remember this slide from earlier that showed us how the GP offers some beneficial coverage areas versus our competing products. Now, let's add in the AH. And you'll see here that the AH is a very capable product. It can go into this application, and it still offers significant benefits versus competing products. Instead of being 12-foot back, we can be 9-foot back. And that 9-foot back is going to result in, again, more room to work for our field personnel. The only real drawback to this type of arrangement is the fact that we're going to be back in this 2-inch installation zone for the deflector, which is important primarily for dry systems. As we said before, this is going to be one of those things that means you can only do a maximum line of 40 foot when the sprinkler is attached directly to the branch line. If that is something you're concerned about, the GP probably is still the better product to be using in that application. As we said, it comes in 2 models with 4.2 K factor, and it has 1 listed flow and pressure because as a unique spray pattern, we can't do this like an area density. That is a bit of a differentiator compared to competing products. So this is 150 square foot, flow rate 15 gallons a minute, 12.8 PSI. And our 5.6 K factor, same situation, 150 square feet, 15 gallons a minute, 7.2 PSI. Now I just want to talk hydraulics a little bit. I know we touched on this a little bit in the last presentation about using standard spray products. Now let's talk about how this works out with some attic sprinkler products. First, we'll talk about a 70-foot layout that uses the competition's special attic sprinklers. You'll see we have our dual direction products located at the peak, and down here we have attic upright technology indicated by the circle with the P in it. And this is a 3-line situation that has 36 sprinklers. Calculations on a dry system is going to be 7 of those sprinklers at the peak, and then adding in 2 of these sprinklers down at the eave. When you do that, you end up with 296 gallons per minute being the minimum demand hydraulically for this system. So I know that there's going to be situations with over discharging and everything else, but what we're doing is just adding up the minimum flow rate for each one of these products because it gives us a baseline to talk about. Without running proper hydraulic calculations, we won't know the end result, but we will know for sure that's going to be more than 296. We talked about Reliable and its ability to use these sprinklers up to 70 foot. So that layout before that had 3 branch lines and 36 sprinklers could be reduced to a single branch line and 24 sprinklers. And just so we know, in gable attics with standard spray uprights, that's 75 sprinklers and 5 branch lines. So we're starting to see significant economies of scale saving us with these types of sprinklers. When we do a hydraulic calculation for this, we're going to add 7 sprinklers on a dry system, just like before we talked about. But I mentioned this earlier and it might not have registered when I said it, but you're going to calculate 7 of these sprinklers on a dry system. And that is with the 5 foot at 70. Now, if this was a 60-foot attic, we would calculate 7 of these sprinklers. And we talked about the flow rate being 22.6 and 38 gallons a minute. So 70 foot in this instance is not any more demanding hydraulically for sprinklers located at the peak. But what we're going to be able to save with this application is the amount of gallons, because there were 2 sprinklers down at the eaves that added 30 gallons a minute for that type of setup. That's missing. So we're saving branch lines, we're saving the total number of sprinklers installed, and we know that when it comes time hydraulically to calculate, we're going to have the need for less water, and the PSI is not going to be any worse. So the DD80 with the 70-foot is an amazingly powerful product. But let's completely switch this around and look at another way of doing 70. Here we have 70-foot layout, and this looks a little bit similar to the first thing that we showed you with competing products, but we're going to use reliable products. And what you're going to see here is we have our dual direction products, the DD80 located at the peak, and we have our AH products down here at the eave. Now these could be GPs as well, but these are AHs for this example. And we have 3 lines, and we have 36 gallons a minute. And we have 36 sprinklers, so 3 lines, 36 sprinklers. This is very similar to our competition's product. So where is the benefit? The benefit comes at the time of calculation. What we are able to do with this layout is, instead of calculating these sprinklers for a coverage area that is out around 60, 63, etc., we could then say that these sprinklers are only going to cover 40 foot. Now, the reason why this is so huge is because we end up having less sprinkler demand gallon-wise in this area, and we have a very low end sprinkler pressure right here, 9.8 psi. Huge, huge. So if you have this attic that goes to 70, and you have this situation where you do not have a lot of pressure and you just can't make that 22.6 end sprinkler pressure work at the peak, knock back the coverage, go with the 6 at 40, and then add support sprinklers in. Now, this just doesn't have to work for 70. I mean, this could be done with a 55-foot span. It could be done with a 60-foot span. You have that flexibility to calculate here, add in sprinklers, and then add them in. So the result is you save 13 pounds of pressure, and you also save 90 gallons per minute at least. All these things, you just need to understand this is all powerful stuff to use in your toolbox when you're doing design for these types of products. And Reliable offers some added benefit and flexibility that you haven't had for 2 decades. So please, try and understand all these concepts and how to do your estimates and design. And lastly, we'll talk about is utilizing AH products in the HIP and how they're beneficial. So here we have a HIP area that uses standard spray sprinklers, and in this whole attic depicted here, we have 65 sprinklers in total. We need to calculate according to FPA 13 for a dry system, full 2,535 sprinklers in the remote area. In this instance, it ends up being 29 sprinklers. And the coverage area for these products is going to be 120 square feet, 7 psi, resulting in 14.8 gallons per sprinkler. That needs a total of 563 gallons per minute. So very, very high flow requirement, very low end sprinkler pressure requirement. We have the ability to utilize, with reliable attic sprinklers, dual direction products at the peak, and you have the ability to use standard spray sprinklers in this HIP area. Now, in this instance, we would use 20 standard spray sprinklers to do that HIP. In order to calculate this, we would do, again, the 2,535 remote area. So that's going to incorporate the entirety of the HIP, and then it's going to need to pick up additional dual direction products. And that calculation is going to be a little bit more beneficial. We're going to get 376 gallons per minute. It's a little bit better than that 563 we just depicted a minute ago. Now, we want to show you a layout that incorporates our competitors' attic sprinklers. So there's their dual direction products located at the peak. And now we have their attic uprights all spaced throughout here. And one of the things you guys might be able to see just by looking at this layout is that it's a little bit different. I mean, it's like we got the stagger going on here. So this is truly different than what we just showed you with standard spray sprinklers. But what isn't different is the number of sprinklers. We just did this hip area with attic upright products and we're at 20. And remember, the standard spray sprinklers were at 20. Now, with this layout, you've saved nothing in the way of sprinklers, right? So what's the benefit to using an attic upright product versus a standard upright product from our competitors? Well, it all has to come down to the hydraulics. If we look at the hydraulics, we have to do two calculations and pick the more demanding of the two. In this instance, we have our dual direction products located at the peak, and we have to add 2 sprinklers from the hip. And in that instance, we end up having 296 gallons a minute being our minimum demand. Next calculation that needs to be run is the entire hip area until we hit 1,950 square feet. Now that's the nice part about these products from UL standpoint is we install them under a slope and we run full-scale fire testing under a slope. In that instance, there's no need to penalize us beyond the fact that we're doing a dry system. So it's 1,500 dry system penalty for 30%, takes us to 1,950. And now we're looking at not needing to go to the 2535. When we run that calculation, the minimum for those number of sprinklers in that hip are going to be 296. So they're equal. Both those were equal as a minimum demand. Moving on to the AH, right then and there, the AH is giving us savings of sprinklers. We went from 20 to 15. So that's always nice. The ability to design less and buy less and install less. When it comes down to the hydraulics for this type of product, it's important to point out that we mentioned the AH56s are a listed product with a flow and pressure. And that means that we actually flow 15 gallons a minute over 150 square feet. With a 5.6 K factor, that's going to be 7.2 PSI. We're pretty much perfect on flow for this type of product, and our delivered density is going to be 0.1. That can't be said of the competing attic uprights out there because we talked about having less coverage area and we look at the required flow rate. These are area density products. You don't see this on their bulletins, but now they're actually 4.2 PSI for that 5.6 K factor, which means that, that's not possible. So we need to increase the flow, get us up to 7 PSI. And now we're looking at, instead of delivering a 0.1, we're delivering a 0.13. So we're over discharging. We're going to put a lot more water into that light hazard space than we need. And always, if you're looking at a worst case scenario where the roof slope is higher, we're still perfect, 0.1 density. These guys here, they get further away from 7 PSI. They're now going to need to over discharge even more. And now we're looking at rounding this up a 0.15. So just selecting competing attic upright technology, you're going to deliver an ordinary hazard group 1 density into that hip. And you just can't avoid it with that 5.6 K factor on a dry system. It's going to come out to work out that way. For our calculation, 7 of these sprinklers plus 2. We're going to need 296. That's exactly the same as what we talked about before. But now with this hip area, we're going to calculate again the whole thing up to 1950. And in this instance, by saving those 5 sprinklers, we're going to now have a lower flow rate of 225 versus that 296. So now our hip doesn't look like it's the most demanding. We save you sprinklers and we're going to potentially save water in that hip and not make it the most demanding area of the system by going with Model AH sprinklers. I know this has been a lot to cover in 2 webinars, and if there is any additional questions, I would ask that you reach out to our technical services department. I can be reached there, and so can my colleagues. Monday through Friday, 8:30 a.m. to 5 p.m. And now we can take some questions and answers.
Thanks, Brandon. Obviously, you did a wonderful job again. We have one question that has come in, and that question is, the GP56, can you use these back to back on a dual slope up to 30 feet wide as long as they are 6 feet apart without a draft curtain?
That would be in line with our dormer installation for that product, so I would say yes.
And I would agree with you. And that's the only other question. Appreciate it, everyone. Brandon, good job as always. Lindsay, great job as always. And we will see you on the next Reliable webinar.